We're going to find A and B. We're given 2 points and there are 2 numbers that we need to find. We've got 2 parameters that we need to evaluate. Is another way of saying the 2 numbers. A and B are parameters for this function. If we're going to try to find 2 parameters, we're going to need 2 equations. We could get an equation from each of these points. When x equals 6, y equals 10. So the form of the function with the 2 parameters, we plug in x equals 6 and y equals 10. We get a 10 for y. And we get a 6 for x. So x is 6, y is 10. When x equals 14, y equals 10. Yeah, what I said was logically correct, but y is not 10, it's 3. So I'm just going to change my 10s to 3. You were confused by that. Good reason for it. So when x equals 6, y is 3. So we're putting in 6. Well, 6 for x and 3 for y. There's our equation. When x is 14, y is 10. So 10 equals a times b to the 14th. Here's an equation. Here's an equation. Okay, so now our system of equations . Okay, well, I'm going to put the things I'm solving for on the left because that's just where we're used to seeing them. It's not incorrect to have them on the right. It's a little less confusing to have them on the left because that's what you usually see in the examples. That's what everybody pretty much does. If you like doing them on the right, go ahead. I can handle it. Okay, but I'm going to write them the way you're probably going to want to see them written. And we're going to have AB to the 10th equals AB to the 14th, I'm sorry, equals 10. Solve the system for A and B. How do we solve the system? Strategy is going to be, we're going to solve the first equation for A and then plug whatever we get into the second equation for A. Okay? And we're going to divide both sides by b to the 6th. And hopefully it's obvious that what we get is A equals 3 divided by b to the 6th. I'm not going to write out every step of that because it's pretty obvious. If you have 2x equals 7, you're going to get x equals 7 over 2, right? Same thing. Just going to divide both sides by b to the 6th, and there it is. We plug that into the second equation. So A is going to become 3 over b to the 6th, multiplied by b to the 14th. That equals 10. Notice that now we only have one variable in the equation. As we solve this equation, it gave us a in terms of b. So when we plug this into the second equation, we have an equation with just b. No a there. Okay, so we simplify this. This gives us 3b to the 8th equals 10. Because b to the 14th divided by b to the 6th is b to the 8th. You subtract exponents when you're dividing. So I have to come up here. So let me just rewrite that 3b to the 8th equals 10. That means that b to the 8th is 10/3. So now all we have to do is find b. The way everybody should understand, if you understand the rules for exponents, because some people are really uncomfortable with roots, and some people are very comfortable with roots. Okay, so I'm going to write this as b to the 8th to the 1/8 power equals 10/3 to the 1/8 power. B to the 8th to the 1/8, and I will write out the step here, means you're doing a power of a power, you're going to multiply the powers. You're going to multiply 8 by 1/8. That's 10/3 to the 1/8. 8 times 1/8 is 1. B to the 1 equals 10/3 to the 1/8. Of course, b to the 1 is just b. And 10/3 to the 1/8. Well, what'd you make me do that for? Okay. Well, I'll figure it out in my head. That's 3 1/3. That's a square. Okay, so the square root of that would be about 1.8. Square root of that would be about 1.35, which would be the 4th root. And the square root of that would be about 1.17. So I'm going to say it's maybe about 1.17. But with a question mark there because I did it in my head. Okay. Now that could also be, and is the 8th root of 10/3. You know how to deal with it. Did I get it?
1.162. So
16 what?
162.
162. You better get that thing fixed.
Okay.
Okay, that rounds off to 1.16. Now hang my head in shame. I seem to be incapable of copying the right number when it's right there in front of me. But I can do the math. Okay. I don't know, something's going on this week. Writing down wrong numbers in the wrong place. Anyhow, keep an eye on me. You never know what I'm going to do. So that's approximately 1.16. Well, a equals 3 divided by b to the 6th. Okay. Now, what's a 6th power of 1.16? If I square that, I get about 1.25. If I cube it, it's going to be like 1.6. 3 divided by 1.6. I think that's going to be about 1.8 or so. Big question marks there. I got it in the calculator. Somebody can tell me what it really is.
1.16.
1.16. Well, b is 1.16. You got to raise b to the 6th and then divide that into 3.
Okay.
Also, somebody out in the hall keeps answering my questions. Remember, we don't want to talk on the campus. Although everything you're doing is great. Let's just see. Yeah. Huh? I don't know your fingers. Okay. Okay, excuse me. What, something? Okay, something's wrong with my brain. 1.16 to the sixth power. I'm thinking is a little less than 2. Number a little less than 2 divided into 3 is a little more than 1.5. But I'm looking at the calculator and it looks right. So I'm going to check this out. Okay, I stand corrected. I did something wrong with the mental calculation. In any case, this whole procedure is pretty simple, especially if you use your calculator to do calculations, okay? Don't do me your head. What I did was I squared this, multiplied it again. I got something like 1.6. Square 1.6. Yeah, I did one little haywire thing. Okay, so anyhow. These are approximations, but it's approximately 1.16 times 1.23 to the x. And there's our function. So now we can complete this. 1.16 multiplied by 1.23 to the x. So the process is always the same. If you know 2 points, you just do these steps and everything works. Okay. Now, let me quickly review something we did in the support course. I just point at the board. Here we have a white graph. That's our graph of y equals f of x. That graph happens to be log base 2 of x, but it makes no difference. What we want to do is we want to take that graph and see how we can transform that graph into the graph of g of x, which is 1/2 f of x plus 3 plus 1. Okay, well, what is this form here? You should remember, because we've done it many times, but if not, I'll keep reinforcing it because it's going to be a big deal on the exam. Okay, this is a series of stretching and shifting transformations of the function f, where the number a, it's of the form a f of x minus h plus k. A is your vertical stretch factor, and it's actually a stretch, compression, reflection factor. It tells you whether you're stretching or compressing and whether you're reflecting, okay? If A is bigger than 1, you're stretching. If A is less than 1, you're compressing. And if A is negative, you're reflecting across the x-axis. Everybody should have that down completely. If not, take my words and keep looking at them every morning and start applying it. Okay, I think the people who are here today, and most of the people who are still functional in this class, have a pretty good idea of that, but let's make it solid right now. You just had your last assignment on using shifting and stretching transformations. Okay, now f of x minus h, h is your horizontal shift. Plus k, that's your vertical shift. We're going to see why those are what we say they are in just a minute. In this case, h would be -3 because x minus h has to be x plus 3, right? So x minus -3 gives you x plus 3. So your horizontal shift is -3. Your vertical shift is 1. So you should immediately identify that. When you see this, say, okay, there's every y value is going to become, every y value of f of x is going to become half as great. What that means is every point's going to move twice as close to the y-axis. It's going to move on the same side of the y-axis because that's a positive factor. If it was a negative factor, it would move on the other side of the axis. It would reflect, okay? And then we got to shift every point 3 units to the left and shift it 1 unit up. We do that with all the points. Okay, so this red graph, can you see that every point on the red graph is twice as close to the x-axis as the point above it on the white graph? Okay, and if we take any point on the y graph and go to the point on the red graph, we're going to go halfway to the x-axis, aren't we? More or less. Remember, this is a hand sketch graph. It's not totally right, but there it is. Every point here is twice as close as a corresponding point here, meaning twice as close as the point directly above it on the f of x graph. Every graph on the red graph is twice as close as a corresponding point on the white graph. So that the white graph has been squashed down by a factor of 2 or multiplied by a factor of 1/2. It's been compressed by a factor of 2, but the factor is 1/2. And 1/2 compresses the graph, as you can see here. Then what happens? Every point is shifted -3 units in the x direction. Well, this arrow here, this is x equals 3. That's a shift of -3. Now, we don't have a point here. I'm just drawing an arrow 3 units long in the negative direction. And we apply that arrow to every point on this graph. Now, I'm just going to use the points, you know, the toolkit points that we would use in sketching the log base 2 graph. But every point on the red graph is going to move 3 units to the left, and we're going to get the blue graph. Can you see that? Is that clear from the picture? Should be. If not, you need to draw your own pictures. If you're not drawing pictures like that, you're not reinforcing this. Is that one of you? I don't think so. It sounded like it came really close, like from the camera or something. Camera shouldn't even be functioning, so I guess we're okay. All right, anyhow, and then we vertically shift 1 unit, meaning every y value becomes 1 greater. So there we have the green graph. That's all there is to it. And it doesn't have to be a graph of the toolkit function. I never used the fact that this is a graph of the log base 2 function. I just wrote that incidentally, but you could calculate it now. You could calculate that this equals ½ log base 2 of x plus 3 plus 1. Put in any value of x. Put in x equals, we'll take a graph, a value that we have here. Put in the value x equals 1. You get log base 2 of 4, right? And half log base 2 of 4 is 2. Because 4 is 2 to the second power. This is the inverse of the toolkit exponential function, the base 2 log function, the base 2 exponential function. Okay, so you put that in, you're going to get 2, half of that is 1, add 1, you get 2. Now, I said that fast, you might not follow every detail, but this says when x equals 1, this formula gives you 2. Well, here's the line x equals 1, and here's the graph. Actually, I drew that point a little low because I didn't want to overwhelm this one. But if I raise this point here where y equals 1 up a full unit, I get y equals 2. This thing gives us the same thing the graph does, okay? And this, of course, would be a green graph, which I never labeled and should have. This is the graph of y equals 1/2 f of x plus 3 plus 1. That's this. Put a green circle around this. So it'll look green, and you can see that function. We can also do this using tables. I can use a series of tables to construct the same function. And there's a little more to be learned from looking at the tables. So let's go ahead and see if we can do that. So we have y equals f of x. These are the values we get for the white graph. Move this over a little bit so you can see the graphs. Okay. This is a table for the red graph. How do we get the table for the red graph? We use the same x values, meaning we're looking at points directly above and below these points, and every y value is going to be half. We can check all these y values are half of these y values. Okay. Then what do? Well, we want the graph of 1/2 f of x plus 3. Well, we're going to get the same y values, but the x values are going to have to be 3 less. So that when we add 3, we get back to the original x values and so forth. Now, that's a little hard to understand, but hopefully you can sort that out. We're going to subtract 3 from all the x values we had here. This is 1/4, 1/4 minus 3. 1/2 gives us 1/2 minus 3, and so forth, all the way down the line. Okay? And there are values, and they're going to match the values that we get when we shift these points over 3 units. Then what do? Well, the last step is really simple. In this step, our x values all have to be 3 less, so we get the graph of f of x plus 3. Okay. Here, we just take all the values of 1/2 f of x plus 3, add 1 to all the y values. And I've got one of them wrong here. So I say I've had a rash of looking at the one thing and writing it down. I'm still wrong. I got to add 1 to all these values. That value, x, well, should have been -1. Yeah, that's right. We took this point and raised it up here. I got 0. Okay. I mean, the numbers tell me that. So I had these wrong. Okay. That's the idea. This whole sequence of transformations. You don't try to do it all at once. You do it one step at a time. And you start with the multiplying factor, the 1/2. You do all multiplying factors, which means all shifts and compressions, before you do any of the addition terms, okay? All right. Now I want to come back . to what we did. Here. I've got to have some blank board. Let me rearrange the boards here off screen. Now, again, here we had the form of a function. We had 2 points on the graph of the function. The form had 2 parameters. So we were able to write 2 equations just by substituting the x and y values of each point into the form of the function. And we were able to solve those 2 equations to get the formula for the exponential function, right? We've seen in chapter 2 that if you have two points on the graph of a linear function, you can plug in values, get the y equals mx plus b form. Okay, we've already seen that. You've also seen the problem of finding the intersection point of 2 straight lines. Now let's suppose well, I'm just going to put numbers in here. Okay, so you've got the equations of 2 lines. You see the x and y intercepts are going to be 4, 0, 6, 0, and 0, 4. Okay, if y is 0, x is 6, that gives you the point 6, 0. If x is 0, y is 4, that gives you the point 0, 4. Make sure you're familiar with that. It's important. Okay, so these are 2, and this one would have x-intercept 6, 0, and y-intercept 0, -8. Okay, so we could easily sketch these 2 graphs. They won't look like this, but one will be up, one will be down. They will cross. All right, to find the intersection point, you remember that we can add these 2 equations. So I have equation 1, equation 2. If I add the 2 equations, I get 6x and I get 36. And I get 0, y, right? Now we've done this. Remember doing this? Nobody's showing a light bulb going on. This was in chapter 2. You did it for homework. We did it in class. Okay. So I'm not writing out all the details that I did formerly. You understand why I'm not writing any y down here, right? Because my y's add up to 0 and I don't have to write plus 0. So x equals 6. Now I take that value and I plug it into either equation. It's easier to get my arrow to the top equation. So I'm plugging in here, and that gives me the equation 2 multiplied by 6 plus 3y equals 12, where I'm substituting 6 for x So let's write that up here again. I get 2 times 6 plus 3y equals 12. That's 12 plus 3y equals 12. And you solve that and you get y equals 0. And then you check. You see, if x is 6, you get 12 here and y 0. Well, that's what you get. And if x is 6 here, you get 24. That's going to give you 0. You're going to get 24, right? So both equations check out. Now, what we are aiming at. Okay, well, one more example. Let's say we got 4x minus 6y equals what? Okay, we'll say 36. And 2x plus 4y equals 16. Okay, here's equation 1, here's equation 2. Any of this look familiar at all? I swear we did this. I'll have to go back and look. Anyhow, this is fairly easy to understand. If I write the system again, equation 1, but multiply equation 2 by -2, meaning I multiply both sides by -2. I get 4x minus 6y equals 36. And I get -4x minus 8y equals -32. Now, if I add equation 1 to equation 2, and what I mean by my notation here with the circles and stuff, equation 1 is the equation 1 in the previous step, right? It's not this anymore, it's this. This is the most recent equation 1. So if I add the two equations, what happens? My x's go away. And I have, excuse me, -14y equals 4. So y equals -4 over 14, which is -2 over 7. Well, I plug that back in. I'll plug it into the first equation. I'll bring the over out here like this. And I'm going to get 4x minus 6 times -2/7 equals 36. Which is 4x plus 12/7 equals 36. Now you got a couple of choices. You can write 36 as 252 over 7. If I did that right, I think it's right. Okay. And then subtract 12/7 from it and get 240 over 7. And if you don't want to do that, you multiply both sides by 7. And you get this, which gives you 28x plus 12 equals 252. And x equals 252 over 28, if I've done that right. And then you check and see, make sure it's right. Okay. Remember my advice in almost every case, if you've got a denominator in an equation, you get a simpler equation if you multiply both sides by the common denominator. And you don't have to worry about fractions. You don't ever have to find common denominators. Well, actually, sometimes you do. If you got two denominators, you want to find their common denominator. Okay. Any common denominator is okay. The least common denominator is the one that gives you the smallest numbers, okay? So if I had a fraction with a 7 here and a 3 over here, I'd multiply both sides by 21. Wipes out all your denominators if you do it carefully. Simplifies life immensely. Okay. So there we have it. That's how you solve two simultaneous equations in this form by elimination. This demonstrates the method of elimination. Okay. Why do we call it elimination? Because we're eliminating one of the variables by adding a multiple of one equation to the other. Okay. So I'll lay a little terminology on you. I've got a clean board. I've got one back there somewhere. So the method of elimination we eliminate a variable by adding, there's a G on that, multiples of the two equations. Written very sloppily, but that just says two equations in two variables. We can do it for three equations in three variables. We can do it for four equations in two variables. Okay. We can do elimination. You just pick a variable, whatever variable you want to pick on, and multiply the equations often by different numbers so that those variables match up, one positive, one negative. Okay. And then you add the equations and that variable's gone. It's just a system of two equations and two variables. Then all you got to do is solve for the remaining variable and then plug that into one of the equations and get the variable you started with. Okay, that's what we just saw. Here's a shortcut. Now I'm going to go back to the equation we just have. If I can find that board. I've got to cut a couple more blocks so I can balance these things a little more easily. But the shortcut, let's just take this first system. Okay, our shortcut here's the system. And our shortcut notation for this system just has the 2, the 3, and the 12, and the 4, and the -3, and the 24. This automatically stands for this times x plus this times y equals this. Okay? And this times x and this times y equals this. That makes sense? If we just write them in columns, that means that this is the X column, this is the Y column, there's an equal sign here, and this is the column for whatever's on the other side of the equal. Right? Now, for reasons you won't understand until late next week sometime. You make this into a matrix by putting square brackets around it. Okay? So now these are columns of our matrix, and these are rows of a matrix. Okay? So we got columns, 1, 2, 3 columns, and 1, 2 rows. Okay? And we put a little line through here. Just to remind ourselves that there's kind of an equal sign here. So it's very easy to translate this to this. It's very easy to translate this to this. It's very straightforward. We just remember that everything in the first column is a coefficient of X, everything in the second column is a coefficient of Y. Everything in the third column is what's on the other side of the equal sign. In the first row is the first equation, and the second row is the second equation. That's it. There's no more to it than that. Okay, so what do we do with this? Well, now that I've translated the equation, I'm just going to say, okay, well, we have this matrix now, and we're going to row reduce it. Instead of equation 1 and equation 2, we have row 1 and row 2. And now we write the matrix down again. And row 1 is going to become -2 times row 1. So that's going to be 4, -4, -6, -36. All we've done is multiplied this first row by -3. Fair enough? Or -2. Okay. Second row is 4, -3, 24. Right? And then what do we do? We just write row 1. We don't change it. But row 2 becomes row 1 plus row 2. Now this means row 1 of this matrix, not row 1 of this new matrix. Although it's the same, okay? Since row 1 here is the same as row 1 here, but it won't always be, okay? So we're always referring, row 1 refers back to row 1 up here. Whether or not it's the same as row 1 here, and sometimes it's not. And we add row 2. Well, that means we add the -4 and the 4. We get 0. So we get 0. Then we add row 1 and row 2 here. -6 and -3 gives us -9. -36 and 24 gives us -12. Something's wrong because it's not coming out consistent. Don't see anything up here that I did that was wrong. Yeah, okay, so be it. Anyhow, there it is. Now what we do we divide row 2 by -9. Again, I'm a little disturbed because something is a little bit messed up here, but maybe not. Okay, so we write row 1 down, it's the same as it was. Row 2 becomes 0. -9 divided by -9 is 1. -12 divided by -1 is 4/3. That makes sense? Now let's translate this into equations. And we better get kind of quick, we just went out of time. This means same as -4x minus 6y equals 36. And what's the second one? It's 0x plus y equals 4/3. Well, 0x is just 0. And we don't need a plus on the y. Y equals 4/3 is our solution for y. Okay? Now, the form I've got here is called upper triangular form. And there's a little bit more that we do, but I'm just demonstrating something that we're going to do next week that is a lot of times hard for people to grasp and to get used to, okay? So I'm showing you something that you won't have to do for about a week. Okay? But you want to see it now. What you're going to do for homework is mostly just equations that you solve by elimination, okay? And it's just 2 equations and 2 unknowns. And that's pretty simple and straightforward, especially since I'm sure you did it for homework in chapter 2. Finding where 2 lines cross. Since everybody's looking at me kind of blankly and everybody's looking at me, it did reasonably well on the midterm test. Okay. I'm wondering if my memory is correct or if my design of the course is what I thought it was. Okay. So since I'm teaching the support course as well, it would be possible we did that in the support course and not in here, but I'll check that out to make sure. One way or another, though, the whole process of solving 2 simultaneous equations by elimination is pretty simple. Okay, don't think you'll have any trouble with it. And I think that's maybe all you're going to have to do. Well, that is all you're going to have to do for Thursday. Thursday, we'll start looking at this.